Hello everyone, welcome to another video. This week's topic is backpropagation, and it's a continuation of last week's video where we covered gradient descent. So if you didn't watch the last video, I recommend you check it out, or you might be a little confused about what we talk about in this video. So quick little recap of what we learned, of what we understood about the learning process last week. So we learned that gradient descent is the optimized algorithm used to update weights and biases, and the goal is to adjust those weights and biases so the cost function gets smaller over time. And back in this video, I'm going to be introducing backpropagation, which computes how each of those weights and biases should be adjusted to minimize error. Essentially, backpropagation is equal to calculating the gradients efficiently. So a quick little walkthrough of backpropagation in a neural network. So the first step is to input the values through the network, and it produces an output. We compare the output with the actual answer. And then the hidden layer is where gradient descent happens, as we learned last week, which is also where backpropagation happens. As I said in this slide, it's essentially an extra layer to help it calculate those weights and biases efficiently. So what happens here is a backward pass. So the backward pass determines how much each neuron contributed to the predicted output. It calculates how much each weight and bias contributed to the actual answer by reusing computations from the previous layer. This is the chain of rule calculus. So essentially, it gets the answer from the last output, and it uses that to continue the algorithm. To continue what we're gonna be talking, I'm gonna be talking about this next week. When I talk about GPT. And so we're gonna leave that for next week. And after that, it uses gradient descent to modify weights and biases in the correct direction. And you repeat this process for all the training data, and the network gradually refines its understanding of digits. So you get each neuron, and you do it across all neurons, aka all the training data, and the network refines its understanding of digits. Another important thing to talk about is stochastic gradient descent, which is a way of speeding up learning. The way it works is you shuffle training data and divide it into small batches. You then compute updates based on those mini batches, and over many steps, the network converges to a good solution. The benefits, as I said, it speeds up learning drastically. And instead of computing the gradient over the entire data set, which would be really slow, it uses mini batches. And if you took like any classes, any sorting and algorithm classes in college, then you understand why this is much faster than doing over the entire data set. And this allows the network to update weights more frequently, while leading to faster convergence. In summary, backpropagation is a way to efficiently calculate the gradient. It determines how each weight and bias should be updated. Sophisticated gradient descent makes it even faster by, instead of doing the full entire data set, we use mini batches to more efficiently, this is more efficient way to scale to larger data sets. The next topic I'm going to be talking about next video is transformers, aka how large language models work, such as ChatGPT. And thank you for watching this video. See you next week.